Hi, myself Gautam Kumar T. I'm from Shivankeshwar College of Engineering, Bangalore. Today, from the subject Computer Networks, I'm going to be explaining about guided transmission media. First, let us look into the contents. Contents. First, we'll start with the introduction. Then we'll move on to the types of guided transmission media, that is twisted cables, coaxial cables, fiber, optic fibers, and applications. And then we'll conclude. Now first let us look in the introduction. Introduction. Guided media is like a physical medium via which the signals are transmitted. They guide the media in use to providing the conclude of from one machine to another. That can have twisted pair, coaxial cable, fiber optical cable, also known as bonded media. Now let us look into the types of guided media. There are three types of guided transmission media. First, we start with twisted pair cables. A twisted pair cable system is a cable consisting of one or several pairs of copper wires. These wires are twisted together around each other and are insulated with dielectric poly compounds. Now let us look into the second one, that is coaxial cables. Coaxial cables is an electrical cable with copper conductor and an insulator shaded around it and a barrier of metallic mesh that prevents signal interfering and crosstalk. Coaxial cable is also known as coax. Now the third one is fiber optic cable. A fiber optic cable contains anywhere from a few to hundred of optical fibers within a plastic casing. Now let us look into the each of the guided transmission media deeply. First we'll talk with start with twisted pair cables. As you can see in the image, the twisted pair cables have two conducting that are gently made up of coppers and each conductors are having insulated. These connect these conductors are twisted together, thus giving this name twisted pair cables. One of the conductor is used to carrying signal, another is used to ground ground reference only. The receivers use different of signals between this conductor and the noise or crosstalk in the parallel conductor is high, but it is generally gently reduced in twisted pair due to the twisting characters. Now let us see types of twisted pair cables, that is unshielded twisted and shield twist cables. First we'll see unshielded twisting pair cables. These are the pairs of two insulated copper wires together with the without any other insulation or shielding, hence it is called unshielded twisted pair cables. This reduces the external interference due to the presence of insulation. Now let us look into the shielded twisted pair cable. These are the types of cables having extra insulation or providing covering over the other conductor in form of copper bands covering. This covering provides a strength to overall structure of cable. It also reduces noise and signal interference in the cable. Now let us look into the coaxial cable. Coaxial cable is an electric cable with a copper conductor and an insulator shield around it, and its baric metal mesh it prevents a signal from interfering and cross-talking. The core copper conduct is used from transmission signals, and the insulator is used to provide the insulation to the copper conductor, and the insulator is surrounded by the bare mesh conductor which helps to prevent the interference of electrical signal to prevent the cross talking. This is the electrical signal prevent cross talking. This entire setup is against covering of prototype plastic layer of ex- providing extra safety to the cable. Now let us look into the structure of coaxial cable. Copper conductor. The central conductor which is consists of copper. The conductor is point at which the data transmit. The insulator. Dielectric plastic insulator around the copper conductor. It uses to maintain space between the central conductor and the shield. Bare mesh. A bare mesh of copper helps to shield from electromagnetic interference. This braid provides barrier against EMI movements into the and out of the coaxial cable. protective plastic layer, an external polymer layer which as a plastic coating is used to protect the external layer from damage. Now let us look into the optic fiber optical cable or optic cables. Fiber optical cables use light signals to transmit data. This consists of thin strands of glasses or plastic that carries light signals for over a long distance. Fiber optic cables offer high bandwidth, low signal loss, and immune to electromagnetic interference. Let us look deeply into the optic. The main element of fiber optics is the core, candle, and buffer coating. First, we'll see into the core. It is a central tube of very thin size made up of optically transmitted dielectric medium carrying the light transmitter to receive, and the core of diameter may vary from 5 um to 100 The candle, it is the outer optical material surrounding the core having the reflecting index lower than the core. Canning helps to keep the light within the core throughout the phenomena of total internal reflections. Buffer coating. It is a plastic coating that protects the fiber made up of silicon rubber. This type of medic is conducted from between 250 to 300 UMs. Now let's look into the applications. Reliability, security, and high bandwidth data integrity. Guided media is generally more reliable than the unguided media, that is wireless, and it is less suspicious to the environment. It does not harm the environment. Security. Wired media offers high level of security since the signals are confined within the physical medium, makes it more difficult for unauthorized access. Higher bandwidth. Guided media offers support higher bandwidth, allowing the transmission of large amount of data at faster rate. Data integrity. The chances of data loss are minimal in the guided media due to the control over the environment within the cables. And disadvantage of guided transmission media are physical limitation, installation and maintenance cost, limited bandwidth for some types, and limited range. These are the disadvantages. Let us look deeply. Physical limitations. Guided media is a physically bounded by cable within which can be mobilized and fixable. Installation maintenance costs. The installation of guided media can be expensive, labor intensive, especially for layering cables over a long distance through complex environment. Limited range. The range of guided media is limited, particularly in comparison to some wireless technologies. Representing or amplifying may be required for long distance of transmission media. Then we see about the application of guided transmission media. It is applicable in telecommunication, LANs, wide area networks, internet connectivity. And let us conclude the topic. The guided transmission media includes twisted cables or coaxial cables, fiber optic cables, remains core stones in the modern communication system. It is reliable, secure, featureless, and capacity of high-speed data transfer makes it eternal in applications such as telecommunications, networks, industry settings. While facing challenges in industrial costs, the guided media continues to be reliable and crucial important to the world, ensuring the seamless flow of information across divisions and domains. Thank you.